Hey everybody, welcome back to the channel. This is a controller for a three-phase permanent magnet motor. Now this is very intricate. You can see it's got everything in there. It's just a block diagram, which is why it's so hard for people to build these kind of things. But if you'll notice and think about my last video, 1, 2, 3, 4, 5, 6 transistors. There's your H bridge. Okay, you got output 2 or 3, 2, and 1. You got a sensor. You got your comparators, your flops. This is coming from your Arduino. 1, 2, 3 gates, 4, 5, 6 gates. See that? This is the same thing that I've been telling you guys. It's very easy to build. There's no need for any of this junk. It's been on there so long. Yeah, I figured I'd make another video real quick, and well, here we go. I'm going to build this for you and show you how it works. And I'm not going to show it live because then, well, I'll have unwanted guests. And if you want to call me a fraud, you can kiss my ass, because I don't care anymore. I really don't. Now this is how I built mine. I did skip a couple of steps, but I'm not building something that's good for all motors. I'm building something that's good for my motor. And this will work for y'all's three-phase permanent magnet wash machine motors. And I would like to give a very big thanks to Omar David Munoz for his senior project on this, for his three-phase variable frequency drive, because if it wasn't for this, all of this that I read, I wouldn't have been able to build mine. And well, let me show you. It's literally it's explanations, it's step by step, it's everything, and it's for free. It is on the internet. Let's see here. I don't remember the exact web address that I got this for, but it's in here. I'll show it to you here in just a minute as soon as I find it. But I want to show you some things on here. Well, if I can find them. If not, then I'll just draw them out real quick. There's part of it. Here's one. Here's one of them. But this is not. Here we go. Here we go. This is what you want to see. Now, this is the H bridge that I built. Mine's not exactly like this one, but this is what you're going to need to control your three-phase motor. So you got one phase, two phase, and three phase. And if you'll notice, you got your positive coming out at different sequences. This is just the route that shows your current flow. You got your output here, your output here, and your output here. And then you can see down on the next diagram, it shows your DC output here, or your negative DC output here, how it comes, and it goes out the same wire on each phase. Now let me explain a little bit about this, because people don't understand it. People that are not, engineers, they don't understand what this is. And basically, here's his controller. Let's see, look right here. and Arduino Uno will be used to drive the gates at logic output voltage of 5 volts. Turn-on times will be determined by a lookup table. These values of this table are synthesized using the current figure in 2.5. See, this is just a pulse wave modulation generation circuit, which is the same thing that my Arduino does. This is a NE555. For my test circuit out there, I used a NE555P because it can handle a lot more. And well, I wanted to buy the best, you know, not just the regular NE555s. I bought the ones that are better and handle a little bit more and a little bit faster, a little bit more reliable, kind of version 2.1 instead of version 2.0, really. But anyways, if you'll notice, this circuit right here, let's see here, what does it say, 1000 hertz and a sine wave varying in frequencies of 40, 50, 60, and 70 hertz through a comparator. Now, I'm not putting a comparator on mine. I'm not worried about the backflow. I'm going to pump a lot of frequency into mine. It's not going to be set up like this with this resistance and this capacitance. Mine's, like I said, mine's not like that. Mine will be custom, but I'm using my Arduino with the coding, so I don't have to, I don't have to worry about none of that. Let's get on with this. Alright. So, let's see here. Does my marker work? Yeah, it works. Hold on one second. Eraser works good? Okay, good. Alright. Now, this is what everybody's been asking me for, and I'm going to go ahead and do this, even though I don't feel like, people that are watching my channel really deserve this. There are a lot of people out there that watch my channel that do deserve this. Terrarium Firma, Cars Are Cool. There's quite a few, websites out there and YouTube channels, like the two I just mentioned, that they have great people running them. They really do. Give a shout out to Jay and Skip and Mona, and you guys, I love you guys all. Olaf, brother, or well, let's just say O. I like to call you O behind your back. You're a great guy, man. I appreciate what you did for me. I really do. Jay, if it wasn't for you, brother, and Terrarium and all these, everybody else, I'd still be where I was. So let's give thanks for that, and we always give thanks to the Lord. If you're up and up on the Bible, you can read Matthew, Mark, Luke. You can read John, and well, you'll find out that we are equal to Jesus. We are equal to our Creator God. We are equal to all. All is equal to us. And when I've told you in the past that we all live each other's lives, well, that's true. So if you're mean to someone, someday that will come back on you. And you will receive equal treatment. So, I got my sandals taken off my feet, just socks here, and we're going to get started. We're going to go ahead and start from square one. Here we go. What is that? That is a battery. Alright, we've got positive and negative. Now this positive and negative is going to go a couple of different places. And I'm not do it like that. So, for one, just for demonstration's sake, this is let's just say a 12 volt battery. It could be a transformer that puts out 12 volts, 500 milliamps, nothing really. Hey, cell phone plug in the wall, it's 6 volts. Alright, there you go, you get the idea. You plug, little square boxes you plug in the wall, your chargers, all that stuff, those are transformers. Those are step-down transformers. And they have diodes in them and other stuff, resistors for the circuitry, to keep them safe. But a lot of them get really hot, and most of them, well, half of them really aren't that safe. But anyways, let's move on. So, let's see here. This is going to go positive, negative, to our, first we're going to go to our controller. And what is your controller? That would be a Uno R3 from Arduino. Anyways, okay, now what is the purpose of having an Arduino Uno R3? Well, we can put 12 volts into it. We can program it with a computer, and it is then a pulse wave modulator, or PWM. That's supposed to be an M. What's the purpose of having a PWM, Tommy? Well, let me tell you. On your PWM, you can have 6 outputs. These two, let's see, positive, negative, positive, negative, positive, negative. Well, what good would having 6 outputs, positive, negative, positive, negative, positive, negative, have for me? Well, let's just look at it like this. If this positive and negative on each one gave us a positive and negative tied together, then it would go from positive to negative on the same wire. So if we were able to do negative, positive, positive, then we would get part of a rotation on a 3-phase motor. And then we could do, just keep in the sequence, negative, positive, positive, and then negative, positive, positive. See what I'm saying? Very simple. But this is not strong enough by itself to control a large permanent magnet motor. Now, it is strong, and keep in mind, a large permanent magnet motor that we are going to be powering, we're not going to run it off of current. It will be run off of voltage and frequency, or voltage and hertz, which is just pulses per second. Or, when you think of, when you think of, say, your house plug-in, it's 110 volts and 60 hertz. That's just 60 pulses per second, or 60 electrons moving past a certain point. And this right here would be where you measure that point, and how many electrons move past that point is how many hertz or pulses per second. They measure it per seconds, and that's how you figure out your hertz. That's supposed to be an H. So, moving right on along. Now we've got our 12 volt battery. It's going to push out about we only need 6 volts, but it can handle 12 volts usually, and this is direct current, so that's not very much. You know, a couple hundred milliamps. I mean, really, you can get that from a very small solar panel, or you can get that from sticking a piece of copper and a piece of zinc in a lemon. I mean, literally, it's not much. But what we're going to do is we're going to take these gates that come off of here, and we've got do it like this so it'll be easier to draw, because I am in no way an artist, not at all, and I don't claim to be. So bear with me here. 1, 2, 3, 4, 5, 6. There we go. Now we've got our H bridge. Now I'm not going to worry about too much of the H bridge right now. I'm just going to focus on the gates on here, and this is going to explain a lot more of my other video for my controller and stuff that I demonstrated for you guys. Okay, so let's see here, gate source drain. So this and this will be connected together, and that's connected together, and these two are ran to. I didn't do the little bridge there. That wire's not connected to that one, so don't pay attention to that. But anyways, and then this one will be the opposite of that, and so forth and so on. But let me just explain what I'm doing here. You've got the 3 wires that are coming out of it that are right here, and they are as follows: gate, drain, and source. Actually, on the NPN, it's gate, source, and drain. Now, like I said, we're only focusing on the gates of the. Man, I should actually draw it from the gate. Okay, of this one. Now remember, we have our positive, negative, positive, negative, positive, negative, that this is going to fire off the controller. So, very simply, we have all these gates wired in to your controller. Okay? Now, on your H bridge, I'm not going to complete the circuit because you get the idea, but on the H bridge, you've got your positive input, and you've got your negative input. Now this is going to be where the enlightenment comes in for you guys. Okay? Yes, I'm using 12 volts to power this Arduino Uno R3, and it's going to power the gates of this. And the gates of the transistors here are going to open when there is a positive or negative voltage applied here, depending on which gate. This gate would be a positive gate, this gate would be a negative gate. Okay, they're both wired to the same wire that comes out, the output, and that is going to go to your 3-phase controller, or your 3-phase motor. This will go to your motor. So you've got your input here that's going to power your motor, and well, we're going to say we need 400 volts, but for the sake of this, I've literally only got access to 220 volts AC, but with 4 diodes and a smoothing capacitor, you can turn that into DC very easily. It's called a bridge rectifier. and that will give us our input from here. So you can use the positive and negative coming off of your 12-volt car battery here and go to an inverter that will step up the voltage and produce a nice little sine wave. Run that back over. I know, you're going from DC to AC back to DC. Why would you do that? Because it's a lot simpler to just plug an inverter into your battery and then take the inverter and put 4 diodes and 1 capacitor on it. Then you have your input for your H bridge right here. And like I said, this is going to be a very enlightened video, because now you know exactly how to build a controller for your 3-phase permanent magnet motor. Are you guys happy that I showed you this? I sure hope so, because, well, I've went through a whole lot of crap because of this project. You know, senior projects are not easy. They're not, you know, oh, wait. I forgot to tell you, in between your controller here, you are going to need some 5K resistors. But in between your pulse width modulator or your R3, your Uno R3, you are going to need some 5,000 ohm resistors. Okay? If you don't put a resistor in there, it's going to backfeed. It's going to tear up your controller. Now, the senior project that they did here, it is completely detailed. It really is. It's got everything here. Here's a printed circuit board diagram. Looking for the coding for it here. Oh, look, that's what they use, but you don't really have to use the exact same thing they used. You can build it for your own motor here. I wish I could find this coding here, because that's very important. But I must have it by my computer. I'm gonna have to type it in, and it's about 2.5 pages, so it's gonna take me, you know, a couple hours to do at least, when I can find the time. But you know, don't forget to, you know, throw me a bone here and at least, you know, give me a little thumbs up, or you know, like the video or something. At least try to help me out a little bit. You know, if not, then, you know, maybe you could at least get on there and cuss me and tell me how big of a piece of white trash I am, and how horrible I am for not teaching you guys anything. And you know, that would help out too. You know, everybody's out there searching for 3-phase motor controllers, and you know, I've already showed everyone how to build a mechanical 3-phase motor controller. That was very simple. I just thought of, you know, how the sequence needed to be, and I just put it together. I believe it's unique. Never heard of anybody else that has one or has ever built one. But you know, if there's a country out there that would like to accept me as a citizen in their country, you know, I'm definitely up for that. I'd like a new life. I really would. I'd like to go somewhere where me and my family are safe and free from tyranny, and free from fictitious state laws and fictitious laws, period. You know, no one in the United States, really anybody, knows anything about common law. And people that do have their rights and hasn't, been stripped away from them yet, have no idea that state statutes are prima fictitious state statutes, that they're not even real laws. And you will get shot over fake laws and for fake companies, and you can just take all your fake stuff and stick it in your fake butt for all I care. That's what I think about it. But anyways, I would definitely like to come to your country and be an ambassador for Gaia. Of course, I probably